Assalamualaikum. This presentation is for our real-time software engineering group project, a smart agriculture hub for food security, AgroShield. This presentation contains our team introduction, the project introduction, problem background, solution, system architecture, and lastly, prototype. Our team members are Labib Hasan, again Shafin, Musfiqur Rahman, Farhana, Taskin, Afifa, Jumana, Taskin, Aumanee. A modern platform aimed at transforming the agriculture sector. The approach ensures data security while providing real-time insights into crop health, soil conditions, and logistics through the integration of IoT sensor networks, advanced analytics, and generative AI. It is now possible for farmers, food producers, and distributors to make well-informed decisions that will boost output, improve food distribution, and encourage sustainable practices. By enabling stakeholders to fight food insecurity and cut waste, the Smart Agriculture Hub opens the door to a more effective and sustainable agriculture ecosystem.
The problem background of our project is the global agriculture sector faces numerous challenges threatening its sustainability: environmental degradation, climate change, resource competition, food security, and economic vulnerabilities. Initiatives like the Smart Agriculture Hub advocate sustainable farming practices like crop rotation, nutrition management, pest control, recycling, and water harvesting to address these challenges. Targeting software developers like the agriculture experts, policymakers, and stakeholders, the hub offers a blueprint for innovative solutions, fostering a safer, more resilient, and sustainable agriculture system. The solution of these problems are sustainable farming practices like promote crop rotation, organic farming, and integrated pest management to reduce environmental impact and enhance soil health. Climate smart agriculture like implement drought resistant crop, water efficient irrigation technique, and carbon sequestration method to adapt to climate variability. Resource optimization like encourage efficient use of land, water, and energy through precision agriculture, conservation tillage, and renewable energy adoption. Food system resilience like develop robust supply chains, market linkages, and food storage facilities to improve access to nutritious food and mitigate the impact of shocks. And the last one is empowering smallholder farmers like provide training, access to credit, and technology adoption support to enhance productivity, income, and resilience.
So I'm going to talk about the system architecture of our system. The system architecture we will be using is the microservice architecture. So this microservice architecture has four layers. First one is presentation layer, second one is business logic layer, third one is integration layer, and the last one is data access layer. So if we see in the presentation layer gives stakeholder access to a user interface where they can see real-time data, analytics, and suggestion. Serving as a front-end specialist, this service provides interactivity and visualization. For our system, it can be mobile app service and the dashboard where farmer and system admin can see and access to the data. The second one is business logic layer, which contains the fundamental reasoning, procedures, and guidelines of the application, overseeing tasks like analysis, judgment, and service coordination with the system. For our system, the business logic layer will have analytics service, agriculture operation service. As we are using machine learning, so AI and machine learning services and the notification service. The third one, integration layer, will provide the infrastructure required for the routing, security, and asynchronous messaging, enabling smooth communication and data sharing between the microservices and external services. Which means the integration layer will work as the communication system between the layers, and the business logic and presentation layer and data access layer will be communicating using this integration layer. So for our system, the API gateway service, messaging service, and external integration service will be the integration layer. And the last one is data access layer, controls how database and storage system communicate with each other, guarantee the application ability to retrieve, store, and use data. So the data access layer will have all the sensor and the data for our system. So in our system, the data access layer will have database service and data aggregation service. So this is the system architecture of our system with a brief description. Thank you.
Let's look at the prototype demo. Our app starts with the opening screen where we present our logo. For the authentication, at first, users are directed to the login screen where they have to input their registered phone number and password. If the user is new in the app, he will be directed to the sign up screen where the user will input all the necessary information and have to choose if they are a user or an officer. For mobile verification, this screen is to ensure secure data and conversation among users. For the landing page, we have put 5 main modules of our app in form of categories, which are crop information. This screen allows farmer to take photos of the crop. AI swiftly detects any crop diseases or pests. It provides a list of resources, including pesticides and remedies for further guidance. Weather forecast. This screen presents current weather conditions and forecasts relevant to agricultural activities. Crop control. This screen presents current weather conditions and forecasts relevant to agriculture activities. Analytics dashboard. This screen offers advanced analytics and insights derived from agricultural data collected by the system. It includes predictive models, trend analysis, and scenario simulations to support decision making. Help Center screen connects farmers with agricultural officers for queries on farming and analytics. Real-time chat support is available during operating hours for immediate assistance, fostering collaboration and enhancing agricultural productivity.
As you can see, crop information has 2 pages, which is detection camera and recommendation of resources. Crop information screen let farmers take photo of their crops using their phone camera. After snapping a picture, the app's smart technology quickly checks for any diseases or pest in the crops. You will get an instant result on their screen, along with helpful tips on what to do next. Plus, they will handy list of recommendation products like pesticides and natural remedies, complete with instructions and how much to use and how much to apply on them. This makes it easy for farmers to take care of any crop problem right away, ensuring healthier harvest and suitable farming. Weather forecast. Weather forecast screen provides users with accurate prediction to help plan their farming activities efficiently. Farmers can access detailed weather forecast including temperature, humidity, and wind speed. With the weather forecast screen, users can stay ahead of changing weather conditions and optimize their farming strategies for improved productivity and sustainability. Here we can see for crop control there are 2 pages, which is input data and data collection. Crop control screen in our app acts as a direct link between sensor and the data they collected. Through this screen, farmers can easily access real-time information about the healthier on their crops, all gathered from the sensors placed in their fields. The screen displays key metrics such as soil moisture level, temperature reading, and other instructions for crop health.
For the next module, we have the analytics dashboard. As you can see, we have allocated 3 screens for showing the statistics and the analytics of the crop health. So this dashboard screen uses the information from the sensors to give valuable insights into the farm, and it gathers the real-time data from the sensors placed all over the field. And it includes the details about the soil moisture, temperature, humidity, and health of the crops. And our app also uses a smart technology to analyze the sensor data. It helps to spot the trends, patterns, and any potential problems with the crops or the soil. And by using those data, our analytics dashboard helps making smart decisions about watering, fertilizing, or improving the farm's productivity. For the last module of our app, we have chosen the Help Center. So when we click the button on the home page to take the help, it directly leads to the chat interface that you can see here. This is mainly the Help Center screen. This screen connects the farmers with the agricultural offices for queries on farming and analytics. Farmers submit their questions on the crop management and pest control, which are routed to different relevant experts, and it offers categorized topic search and a knowledge-based self-help. So real-time chat support is available during operating hours for immediate assistance, fostering collaboration and enhancing agricultural productivity. So that's it for our project proposal and prototype demo. This is the group discussion that we have done so far. I hope you like it, and if you have any questions and replies, please put it in our forum discussion. Thank you for listening to us.